Oh, there. So today we're going to be doing a brief introduction to Python programming. So this will just be enough to understand the syntax of the language, how to use it, and how to do those exercises that will be coming up. Okay, so let's get started. So first of all, what is programming? So programming is about manipulating data. Okay, so we are going to be inputting some data from some user or a source. So we input data. Yeah, so this can be from the user where you can request input. It can be from a file or some other source like that. Then we're going to perform some operations on this data. Okay, so that's the bulk of the program is to perform the operations. And then once that is done, we're going to then output the data. So we can output back to the user, we can output to a file, something like that. So output data. Okay, so in all of these steps, this data that we're going to be inputting, performing operations on, and finally outputting, this data is stored in the form of a variable. Okay, so variables in programming store data. Okay, so these variables come in different types. Okay, so if we have different types of data, we're going to have different types of variables that store that data. So the types that we're going to be focusing on are integer type. Okay, so this is almost exactly the same as your mathematical integer. So positive and negative whole numbers. So something like -2, -1, 0, 1, 2, and so on, things like that. Okay, the next is a float. Okay, so don't worry too much about the name. A float is just a decimal form of a number. Okay, so something like 3.141, 2.786, something like that, some finite decimal number. If you want to store that in a program, you need to store it as a float. Okay, the next is a string. So a string is just a word or phrase, something like a sentence that you want to store on the computer. Okay, so strings are represented like so. We have a quotation mark, then we just write out what we want. So physics is fun, for example, and then we have a closed quotation mark. So everything between the quotation marks, that is the string of characters or just string that we want to save. Okay, next is Boolean. So you should be familiar with this from your previous math modules on Boolean algebra. So a Boolean is just a value that can be either true or false. Yeah, and we're going to be using this later on for conditions. So if something is true, we want to do one thing. If it's false, we're going to be doing another thing. Yeah, so that's how we're going to be using these Booleans. Okay, and lastly, we're going to be using lists. So a list is just a list of variables. So in Python, if we want to create a list, we have an open square bracket followed by all the elements we want in the list. So let's say 1, 2, 3, 4, 5, 6. And then we have closed square brackets when we want to end the list. Now, over here, we have all of these variables being the same type, so all of them being integers. However, we can mix and match types in a list. So you can have numbers, booleans, and strings all mixed up in a list. However, the way we're going to be using lists, they're all going to be the same type. Okay, so those are the data types that we're going to be using. Okay, so next, now that we know what a data type is, how do we create a variable? So in Python, creating a variable is very easy. So very easy to create a variable. We simply give the variable a name. So let's say my integer. And we have equals, and then the number that we want to save. So since it's an integer, we can say my integer equals 2. Okay, so this equals over here, we call this an assignment operator. Okay, so what this does is it creates a variable called my integer, which we can use later on, and it assigns it the value 2. Now, what Python does is it automatically figures out what type it is. So since we said equals 2, my integer will automatically have the type integer. So the type is automatically figured out. Okay, so based on what you're trying to set it to, it will figure out that type. Okay, now with regards to this variable name over here, there are a few rules that we need to follow when creating variables. Okay, so rules for variable naming. Okay, so there's not many rules, but just a few that we need to follow. The first one is that a variable must start with a letter or an underscore character. So a variable must start with a letter or an underscore. Yeah, so that's just this underscore character over here. Okay. Number 2, a variable cannot start with a number. Okay. And number 3, a variable can only contain alphanumeric characters. Okay, so that's letters and numbers and underscores. Okay, so just 3 rules that we need to follow with regards to naming of variables. Okay, let's have a look at some of the operations that we can do with these variables now. Okay, so first let's look at integer and float operations. So these are our number operations. So integer and float operations. Okay, so integer and floats, they make up our numbers. Okay, so the first one is addition. Okay, so if you want to add two integers or add two floats or add an integer to a float, anything like that, we use the plus symbol. If we want to do subtraction, we use the minus symbol. If we want to do multiplication, we use the star or asterisk symbol. If we want to do division, we use the forward slash. Okay, so please be careful. Don't confuse your forward slashes with backward slashes. Exponentiation. Okay, this is done with a double star or double asterisk. Okay, so that's if you want to raise a to the power b, you would use this double star. So a double star b, that's if we want a to the power b. Okay, modulus. This is done with the percent symbol. And we have another operation called integer division. Okay, here we use a double forward slash. Now with integer division, this performs the standard division, but it ignores the decimal part. Okay, so it only returns the integer part after division. So it returns the integer part after division. Okay, so if we had something like 5 divided by 2, that would be 2.5. But 5 integer divided by 2, that would just be 2. So the 0.5 fractional part, that is ignored. Okay, so we get an integer value back. Okay, so those are the operations that we can perform on numbers. There are also operations we can perform on strings. Okay, so I'm just going to introduce two of them that are quite useful for now. The remaining operations we will cover later on. So string operations. Okay, so the two useful ones are concatenation. Okay, so this is done with the plus symbol. And what concatenation does is it takes two strings and it just joins them together to make a new string. So if we have a string ABC plus a string XYZ, this will form a new string ABC XYZ as a single string now. Okay, so this concatenation here, it just joins the two strings together. Okay, and then the second one is repeated concatenation. This is done with the asterisk or star symbol. So as the name suggests, it does this concatenation process some number of times. For example, if we have 3 star ABC, this will concatenate ABC with itself 3 times. So we will end up with ABC, ABC, ABC. Okay, so it's been joined together with itself 3 times. Okay, like I said, the other string operations, those will be covered later on. Okay, next, Boolean operations and relational operations. Okay, so these are operations that we're going to be using with Boolean algebra. So your and, or, and not. Okay, so in Python, if we want to use these Boolean operations, we just type them out as is. So there's no special characters for it. We just say and, or we could say not. So as an example, we can have B is equal to true, C is equal to false, and then A is equal to B and C. This will perform the logical or the Boolean and between B and C. So in this case, B is true, C is false. If we AND them, we get false. So A will now be false. Okay, so as you can see, we just wrote it out as a word there. Then we can do the same thing with and, or, and not. Okay, and then the relational operations. So those are relating to things. So most of the time we're going to be doing it with numbers. So that will be less than, greater than or equal to, and so on. Okay, so let's write them out. So we have less than. So if you want to see if A is less than B, we use the less than symbol. Okay, so that's just the open angle brackets. Greater than. Okay, so that's the closed angle brackets. So the same as you would use in maths. Less than or equal to. Okay, so that's less than or equal to. So you just write them one after another. Greater than or equal to. Okay, very similar. It's greater than or equal to. So again, you just write them one after another. And finally, equal to. So remember that the single equals character, that's used for variable assignment. So what we do for equality checking is we use a double equal to. Okay, so two equal to symbols next to each other, that means we are comparing the two objects to see if they are equal. Okay, so single equal to sign, that is for variable assignment. Double equal to sign, that is for equality checking. Okay, and finally, list operations. Okay, so these are the operations we can perform on a list. So the first two is reading and writing from a list. So reading from / writing to a list. So once we have created a list, we can read the different elements to see what they are, or we could write to the list, either replacing an element or adding a new element to the list. Okay, so let's say we have a list. My list is equal to A, B, C. And now we want to access these elements. So if we want to access the first element, we use an index of 0, because in Python, we start counting from 0, not 1. So in fact, this first element here is the 0th element, the second element, that's index 1, and the third element, that's index 2. So we start counting from 0. Okay, so please just keep that in mind. Now, if we want to access the first element, we use the indexing operator. So my list, and then we use the square brackets followed by the index that we want. So if we want to access the first element, we use index 0. If we want to access the second element, we use index 1. And if we want to access the third element, we use index 2. Okay, so this is how we access the elements, and we can use this for other things in our program. If we want to change a particular element, again, we use the indexing operator. So let's say we want to change the second element from a B to an X. We can say my list 1, because remember, we start counting from 0. So the second element has index 1. And then we just say equals X. Okay, so this will reassign that second element to now be an X. So the list will now read A, X, and C. Okay, because we have reassigned that value over there. Okay, so that is reading and writing to a list where we write over what already exists there. If we want to add something to the end of a list, we need to use a function called append. So a function is just a shorthand name that we give to a bunch of code that does a certain task. So if we want to add something to a list, we call the append function, and that will do something behind the scenes to add something to the list. Okay, but we don't have to worry about what it does behind the scenes. We just need to know the name of the function and how to use it. Okay, so adding to a list, we can use append. So my list dot. So if we want to call the function on a particular list, we use the dot. And then append. And then the element that we want to add. Okay, so just a quick little note, this here, my list, that is the list that we're trying to change. The dot means that we're going to be calling a function. Append, that is the function we're calling. Okay, it's going to do a certain task for us. Then we have open brackets and close brackets. That is to show that whatever's inside those brackets, those are called the arguments. So that's extra information we give to the function to do its task. So in this case, we pass in the elements variable, and then that variable will go into the function, and then the function will then add it to the list. Okay, and it adds it to the end of the list. Okay, there are a few other functions. So there is the clear function that removes all the elements from the list, so it clears it out. Index. Okay, so the index function returns the index of the first element with the specified value. So if we have my list dot index C, this will give us 2 because the third element in the list, or the element at index 2, is a C. So this returns 2. Okay, so that's very good if we want to look through the list for a specific value. Okay, then we have insert. So this will add an element at a specified index. We have pop. So this will remove an element from a specified position and then return it to you. Remove, very similar to pop. So it removes the first element, but with the specified value. So pop, you need to provide the index, and it will remove at that index. With remove, it removes with the specific value. Okay, then we have reverse. So this will reverse whatever order the list has. So if the list is 1, 2, 3, and we call reverse, then it will be 3, 2, 1. Okay, and sort. This will sort the list based on some given criteria. So if we have a list of numbers, we can then sort in ascending order, or we can change it slightly to sort in descending order. Okay, but we will take a look at that later on. Okay, so those are the basic variable operations or variable manipulations that we're going to be using. Okay, the next topic is looking at input and output. So like we said in the beginning, with what a program does, it will input some data, perform some operations, and then output the data. So we have a rough idea of the manipulations that we can do to the data, but what about inputting and outputting the data? Okay, so input and output. Okay, so to input some data, we use the input function. So we can have our variable is equal to, and then we call the input function with some kind of prompt. So this prompt is going to be displayed to the user so that they can see what they should input. Then the program is going to wait for the user to type in something, then press enter. Once the user presses enter, this variable will be assigned to whatever the user has inputted, and then the program will continue. Okay, so we call the input function with the prompt. Okay, for example, we can have name is equal to input, and then we can have a nice prompt like, please enter your name. Okay, so this string, please enter your name, that will be displayed to the user. The user can then type in their name, press enter. Once they press enter, this name variable will then take on that particular value. Okay, once we have the variable, we can do various manipulations if we need to. Then once all of that is done, we would like to display some results to the user. And we do that with the print function. So we have print, and then we can list off various things that we want printed to the screen. So we can say print hello, and then we can have comma. So whenever we have a comma in the print function, that means that there's going to be a space in the output. So here we're going to have hello in the output, followed by a space, and then we can have the name variable. So this program will get the name from the user and then print out hello, space, followed by the person's name. And we can have as many strings as we want here. So we can have hello, comma, name, comma, something else after that, as many as we want. Okay, just remember all of it gets printed out to the user with a space in between. Okay, so there are various modifications we can do with this print function, but we're going to be looking at that later on. Okay, just an important note, this input function, okay, always returns a string. Okay, so sometimes we want a string, like in this case, we wanted the name, which is a string, but other times we want the user to input an integer, or maybe input a float or a Boolean. Now, this function always returns a string, so we can't create a Boolean variable with a string input. That's not going to work. The variable will become a string. So what we do is we use type converting functions. Okay, so these functions will take in a given type and return the type that we actually want. So the first one is int. So we've got this function, int. We put in some variable. So maybe it's a string formatted integer or a float or something like that. We can then convert it to an integer. So for example, int 123, this will give us back 123. So it took the string representation and turned it into an integer. If we have int 3.14, then we need to make an integer out of this. So we just take the integer part, 3. Okay, so whatever we put in, this function will try and convert it to an integer. Okay, very similarly, we have float. So this will try convert the inputted variable to a float. We have str for string. So this will turn the inputted variable into a string. And we have bool, so short for Boolean. This will try and convert the inputted value into a Boolean. So just as an example on how we're going to be using this, we can say user integer equals int input enter an integer. Okay, so here we've got a double function call, so a function in a function. So we see that this innermost function input, this will ask the user to enter an integer. But remember, the input always returns a string. So if we want an integer, we need to pass that into the int function so that it can then be converted from a string to an integer. And then finally, we can assign user integer to whatever that integer is. Okay, so we have this composition of functions to get an integer from a user. Okay. The next section that we need to go through is control flow. So far, our programs have just started at a point, done some stuff, and then ended. What control flow does is it allows us to do certain things based on a condition. So if the condition is true, we want to do one thing. If the condition is false, we want to do something else. So the way we do that is with an if statement. Okay, so in Python, an if statement is just done using the keyword if. So we can have if followed by a condition. So this is a Boolean. Then we have the colon, 2 dots. And then on the next line, we need to leave a space or a tab. Okay, so we have tab spacing. That's just part of the Python syntax. Okay, so you press your tab button, that makes an indentation. And then we can write our code that we want performed if the condition is true. So over here, this code will run if the condition is true. If the condition is false, then the code will not run. So that gives us control as to what gets run in our program. So maybe we want something to run if the condition is false. Okay, because as we've written it here, the code there will only run if the condition is true. If we want something to run if the condition is false, we can use an else statement. So if condition, okay, again, we leave our tab. So this code will run if true. Okay, so if the condition is true, we get that code running. Else, so we use the else keyword followed by the colon. This code will run if false. Okay, so we have our if true, do this, else do that. Okay, and then we can specify what gets run in either case. Okay, if we have more conditions to check, we can use an else if statement. So if condition do something, okay, but maybe we don't want to do something strictly if the condition is false. Maybe we want to check something else. So we can use an else if statement. And here we can check for another condition. Condition 2. So if condition 1 fails, then we can check condition 2 and do something else. And we can add as many as we want. So maybe we want to check a condition 3, do something else if condition 3 is satisfied. And if none of those conditions are satisfied, then if we want, we can have an else, do something else. Okay, so we can have as many conditions as we want, depending on what kind of program we're writing. Okay, so along with this if statement to control the flow of the program, we can also use what is called a for loop or a while loop to control the flow. And in those cases, we want to repeat a certain section of code some number of times. So instead of writing the code multiple times, which is called code duplication, we want to avoid that. So we use a loop instead. So we specify how many times the loop will run, and then that section of code will run that many times. Okay, so the simplest for loop is given by the keyword for. Then we specify some kind of index. So this is a variable. It's going to start at a particular value and end at a particular value. And then we can use this variable in the loop if we want to. Okay, it will keep track of how many times we've run the loop. So for index, then we use the keyword in, followed by range. So a range is just it's like a mathematical range. So we have a starting point and an ending point, but in Python, we can also specify a step size. So we have a starting point, an ending point, and a step. Okay, and then we have to put the colon at the end there. Okay, and just, and then over here, we can have some stuff to do. So some code to run. Okay, so let's look at an example. So we can have for I in range 1 to 10 with a step size of 2. And we can say print R. So what will this do? Well, it will repeat this code, the printing of R, some number of times depending on the range that we specified. So we start at 1, so it's going to be 1, and then we go up by 2, because that's our step of 2. So from 1, the next one will be 3. So it will loop and it will run the print statement again, but this time I will have the value 3. Then it goes up by 2 again. It re-loops, so it does the print statement again, but now I has the value 5. And then it does it again with the value 7, then again with the value 9. But on the next loop, if we increment it, it will go from 9 to 11. But 11 is bigger than our ending value of 10, so it stops. So it stops here. Stops here. Because 11, which would be the next value, is greater than 10. Okay, so this range function starts from 1 and goes up to 10. Just an important note, it does not include 10. Okay, so just because we specified 10 there doesn't mean it goes to that value. So we can think of it as 1 less than or equal to R less than 10. Okay, so it does not include that upper bound value. Okay, so this is a ranged-based for loop because we specify a range. we can also have another for loop that doesn't go over a range, but instead goes over a given list. So we can have, let's say, my list is equal to cats, dogs, bears, for example, and we want to loop over all of these particular animals. So we could use a range-based for loop and use the index like we had here, so like this index R. We could use that index to index the particular elements. On the other hand, we could just say for animals, so that's the variable name that we're giving, in my list. So instead of specifying a range, we just provide a list. Yeah, and then it will go through each element of the list. And then we can say print animal. Yeah, and then this will then go through each element in the list and print out that, and then print out that element. So the first element is cat, so it prints out cat. Then for the next iteration of the loop, it goes to dogs, cats, and then dogs. And then for the final iteration of the loop, it will then go to bears. So we will see this as an output. Okay, so instead of going through some numerical order with range, we go through the actual elements of the list. Okay, and finally, the last control flow statement is a while loop. Okay, so a while loop. Okay, so very simple, very similar to the for loop, but instead of providing a range to iterate over, instead we provide a condition. So while the condition is true, it will then execute the code given in the while loop. So while, and then some condition, again, we need the colon, and then code to execute. Yeah, so the way we read it is, while the condition is true, this code will be repeatedly executed. Once the condition becomes false, the while loop will then end. Okay, so let's look at a nice example. So let's say count is equal to 0. Yeah, so that's our initial value for the count variable. Then we can have while count is less than 5. So this is our condition. So the code will run repeatedly while count is less than 5. As soon as count becomes greater than or equal to 5, the while loop will then end. Okay, so we can have print count to see what the current count value is, and then we can have count equals count plus 1. So we are reassigning count with 1 more than count. Okay, so that has the effect of incrementing the variable by 1. Okay, because we are reassigning it with something that is 1 more than the current value. So we call this an increment. Yeah, and then we'll see that it starts with 0, and then you can only increment so much until it becomes greater than or equal to 5. So here, the output will be 0, because that is the initial value of count. Then we increment it and it becomes 1, then 2, then 3, then 4. And then on the final increment, it goes up to 5, but 5 is not less than 5. So the while loop ends. Okay, so we never reach 5 because we stated here that it must be strictly less than 5. As soon as it becomes equal to 5, then it will end. Yeah, so the final thing to look at is the idea of functions. So we've seen functions before with list manipulation. So we had a function that we called using a list, and it did some manipulation. And as I said, a function is just a shorthand name for something that is done behind the scenes, given some input. Okay, so those built-in functions, like with list manipulation, we don't really see what's behind the scenes. We just run the function and it does what we want. However, we can create our own functions to do things. So the way that we do that is by declaring a function or defining a function using the def keyword. So def, then we provide a function name. Yeah, and then we can have various function parameters. So these are the inputs to the function that we need to do something. Okay, so we have various parameters. Okay, then the function will do some operations on the parameters. So some code here to do some operations. Okay, and then finally, we can have a return statement. So sometimes we want a function that just does some things but doesn't return anything, like the print function. So the print function just takes our parameters and writes them to the screen, and it doesn't return anything, okay, because we don't expect some output from that. On the other hand, we could have a function like the input function, where given a prompt, it displays it to the screen and then returns whatever the user typed in. Yeah, so sometimes we want the function to return something, and the way we do that is with a return statement. So we write return, followed by the value that is returned back to the user. So let's look at two examples. So these are mathematical functions. Of course, you can write any function you wish, but what we're going to be doing in the module is mainly mathematical functions. So computer representations of functions that you could write down. So example 1. So we can say def, so define f of x. So this is very similar to a mathematical function, f of x. Okay, so f, that's the name of the function, x, that is our input parameter. Then we can create some value variable, let's say 5 times x plus 1. So this function would be a straight line, okay, based on what we've prescribed there. And then we can return the value. Okay, so given some value of x, this will return f of x. Okay, another example, 2. We can define a function g. Maybe it depends on x and y, so it's a multivariable function. Okay, so there's no limit to how many parameters we can have. Then we can define some value. Let's say it's 5x plus 1 minus y. Okay, so a 2-variable function. Then we can print the value if we want, or we can just return it. Okay, so if we don't have the return value, then this function would calculate the output and simply return it back to the user without returning it as a value to assign to a variable. Or we can return the value and then we can create a variable from this function output. So we can have something like variable is equal to g of 1, 2, and this will then take on whatever value is returned. Okay, So that is the basics of Python programming. So this should be everything you need to know to cover those exercises. And we will look more into this Python programming when we do the tutorial on Wednesday. Okay, so the Wednesday tutorial, that will be a mix of lecture and own work. Okay, so I'll explain some more things and then I'll leave you to do those tutorials. Okay, but you're not on your own. If you do have any questions, please feel free to ask. Okay, so I'll see you in the next lecture. Bye.